Today we're going to study the scientific revolution, a time when people's ideas about the world changed tremendously. Not only will we study the events of this revolution, but we're also going to be able to answer the question, what was the impact of the scientific revolution? Our goals today are threefold. First, we're going to explain how scientific thought changed following the Renaissance. And we'll use that to guide our understanding and analysis of how people and their ideas contributed to the scientific revolution. And then we're going to connect everything that we learned up to this point to really understand not only the scientific revolution itself, but what was its impact. So now let's take a look at some of the key words that we'll explore in this lesson. Now take a close look at these words. You'll see them come up throughout the lesson. At any time that you want to refresh, you can click on one of these words and you can go into more detail about the definition or concept. So we're exploring this question, what was the impact of the scientific revolution? And so in this lesson, we're going to explore how a revival of ancient and medieval science leads to the Copernican revolution, when Copernicus publishes his heliocentric theory. And this sets off a chain of events that brings us into the modern day, the modern science that we know of today. Now, the seeds of the scientific revolution are beginning to form in the 1500s, when many Europeans start to look at the world around them in different and new ways. Now, this is in large part due to two major movements. The Renaissance, which is reviving a classical way of thinking for many people, particularly these ideas related to concepts called humanism and realism. Now, we're going to address both of these ideologies later on in this lesson. As well, something called the Reformation began to cause people to question their long-held religious beliefs. And so the combination of these two movements led to people questioning what they had believed for, in many cases, centuries about the world around them. So by looking at the question of what the impact of the scientific revolution was, we first need to get an idea of how the scientific revolution really developed. What was the foundation? And it actually turns out that the foundation is in this ancient and medieval science that is revived during the 15 and 1600s in Europe. So what we're going to start off with is looking at how this is all coming together, eventually leading to the Copernican revolution and bringing us into the modern science of today. So the Greeks had a very clearly defined system of inquiry for science. They called this natural philosophy. And in this natural philosophy, they believed that they could use logic and reason to solve problems and to make observations about the world around them. Now, many of these Greek philosophers make really important contributions in the field of mathematics. The gentleman that we see on the screen here, his name is Euclid, and he was known as the father of geometry. He wrote a textbook that is actually held up through today in the principles of geometry that we study now. Now, these Greek philosophers are not only influencing math, they're also influencing the way we think about ourselves and our place in the world. Socrates and Aristotle are two of the most famous of these Greek thinkers. Socrates is known for developing a system of questioning the world. He believed that questioning and developing these clear definitions was the way to understand what was happening around us. And we call this system of questioning today the Socratic method. So his teachings have also withstood the test of time. Now, later on, we see another Greek philosopher, Aristotle, develop something called the geocentric theory. And in this geocentric theory, we see that the Earth is believed to be at the center of the universe. Now, for hundreds of years, this geocentric theory held up because it was in line with many Christian beliefs. But during the scientific revolution, we're going to start to see this theory challenged. Let's take a moment to review what we've learned so far. By the Middle Ages, Islamic scholars are building on these early Greek philosophies by making key advancements in areas of mathematics, medicine, physics, and astronomy. Now, these Islamic scholars are responsible for inventing things like algebra, and something called the astrolabe, which allowed us to make more precise measurements of the Earth and kind of what's happening around the Earth. And what we see on the screen here is the depiction of a lunar eclipse as drawn by one of these Islamic scholars. Now, these ideas are going to kind of support the movement as they move towards Europe. We're going to start to see the development of the Renaissance and this age of exploration that's being influenced by these Islamic ideas. And so as we look at kind of how this unfolds, we see that a number of things are occurring at one time. First of all, classical ideas are being revived. So again, these concepts of humanism and realism, which we'll talk about a little bit later. The works by these Arab scholars that we mentioned previously are being translated into European languages now. And the combination of these translations with the new invention, the printing press, is going to help the spread of these ideas. Now, new instruments like the astrolabe, which we see here, is going to allow more precise scientific observation. And so now we're going to be able to know exactly what's happening in the world and surrounding the world. And then finally, the discovery of previously unknown lands, the Americas, for example, is going to inspire people to think a little differently about the world. Now let's take a moment once again to check in and make sure we understand everything we've gone over so far. What was the impact of the scientific revolution? Well, we know that ancient and medieval science is being revived in this age of exploration. But the real turning point in this revolution was when Nicholas Copernicus publishes his heliocentric theory. Now, this happens in 1543. And this is going to kind of set off a chain of events that's going to lead to other thinkers beginning to challenge the science as we knew it. Now, all of these new thinkers bringing these ideas to the table is eventually going to lead us into the modern science that we know today, which is what we'll talk about from this point. So perhaps one of the most radical ideas to come out of the scientific revolution is the heliocentric theory. This is developed by the Polish astronomer Nicholas Copernicus. And heliocentric theory states that the sun, not the Earth, is at the center of the universe. Now, despite the growing evidence in support of heliocentric theory, Copernicus does not publish his theories until he's on his deathbed. Because these ideas directly contradict the teachings of the Catholic Church, he's afraid of pursuing them beyond his own studies. Now, he does eventually publish the work, and other later philosophers and scientists continue to pursue the research that he was doing. Galileo Galilei is an Italian astronomer who continues the work that Copernicus was doing by contributing to the laws of motion. So the concept of gravity comes out of Galileo's studies. He also improves the telescope. What this is going to do is make his measurements much more precise and accurate. Now, he supported Copernicus's ideas, believing in things like heliocentric theory, and as a result, he's pursued and persecuted by the Catholic Church. Eventually, he recants his beliefs and dies under house arrest. Now, the only reason he recants his beliefs is because he's under the threat of torture. He still very much supports the heliocentric theory, but now he's afraid of talking about these beliefs. And so the question we need to ask is, why is the church so fervent in its pushback against these new ideas and theories? And so when we look at kind of the causes and effects of science and the Reformation, we see that the Reformation and the support of people thinking outside of these long-held beliefs is threatening the church's authority. And so as a result, the church begins to persecute those who challenge its teachings, regardless of how much evidence supports those teachings. And so we see that despite all of this evidence in favor of heliocentric theory, the church is in direct opposition of any belief that the sun is at the center of the universe. Finally, as a result of them being so against this theory and the people that support the theories, the church is going to find Galileo guilty of heresy and put him under house arrest for the rest of his life. Now let's move on to see what Galileo had to say about the church. So at the same time that Galileo is pursuing Copernican theories and under the threat of persecution for doing so, another mathematician and astronomer named Johannes Kepler is pursuing some similar ideas in Germany. Now, Kepler is able to take heliocentric theory one step further. He not only proves that it's true, but he discovers a new law of planetary motion. He realizes that not only are the planets orbiting around the sun, but they're doing so in an elliptical shape, more of an oval than a circle. Now, despite the fact that these early philosophers are being persecuted by the church for their new ideas and theories, eventually these true ideas do win out, and the church is not able to kind of contain them much longer. What was the impact of the scientific revolution? This is the question that we're exploring today. We know that the foundation of the revolution is really rooted in the revival of ancient and medieval science. But the turning point was really Copernicus publishing his heliocentric theory in 1543. Now, this is the idea that the Earth is not at the center of the universe, rather that the universe is revolving around the sun. Now, this is going to really change the way people see the world, because now they don't think that they're at the center of it anymore. Now, other thinkers, Isaac Newton, Robert Boyle, René Descartes, they're going to take these new ideas and push them further in the realms of science, math, and kind of scientific inquiry. And this is going to bring us into our modern science as we know it today. So before the scientific revolution, people are relying on mostly traditional beliefs to generate their understanding of the world around them. These beliefs come from church teachings and some form of logical reasoning that dated back, sometimes hundreds of years. Now, after the scientific revolution, when we develop these concepts of modern science, we start to see new practices taking shape. This concept of observing and experimenting and using scientific reasoning to develop new ideas creates one of the biggest new methodologies that we still use today, something called the scientific method. Now let's take a look at how the scientific method comes together. Now, the English philosopher and scientist Francis Bacon is one of the first pioneers of this scientific method, in which you begin by forming a hypothesis. So you come up with some idea that you want to test. You test that idea through experiments. And once your experiments are complete, you begin to analyze that data and try to form some sort of conclusion. Now, you're not always able to come up with a conclusion right away, and so you might have to either repeat the experiment with a different hypothesis, a different test model, or maybe your theory is proven wrong. Now, today we rely on the scientific method for all sorts of technology and devices and medicines that we use. So it does require very careful planning and research, but it's very important to the life we live today. So countless advancements were made during the scientific revolution in mathematics and science, and three men in particular were helpful in moving us forward. Now on the screen you see the images of these three men, starting with René Descartes, who pioneered the coordinate plane system and is responsible for bringing a lot of the algebra and geometry that we still use today into the world. He also pioneered the use of deductive reasoning. After Descartes, we see a man named Isaac Newton build upon the work of Kepler and Galileo by making advancements in the laws of motion. He discovered that gravity, which is affecting the planetary motions around the sun, is also affecting the way things move here on Earth. He developed the use of calculus as well, which was a brand new type of mathematics at the time. And then finally, we see Robert Boyle, who was a physician responsible for developing a mathematical relationship between pressure and volumes of gases. So he developed something that's really popular in physics today called Boyle's law. Now, later scientists would build upon these scientists' work and contribute to the math and science that we use today. So let's go ahead and review what we've learned so far. Along with the revolution in scientific thinking is going to be a revolution in instrumentation. Instruments like the microscope are going to allow for more detailed observations of very, very small things, particularly things like bacteria. We're also going to see improvements in thermometers and barometers, which is going to allow for more accurate readings of what these instruments measure. These developments are going to lead to discoveries in things like microbiology, disease, and weather. And so, as a result of the scientific revolution, scientific study is completely transformed. Royal societies will be founded, meaning scientists are going to kind of organize ways that they can meet and share ideas, which is going to lead to the development of new scientific fields. And as people really indulge in these new ways that they're looking at science and our place in the world as a result of these things, more and more discoveries of the way the world works are going to occur in the 150 years that's known as the scientific revolution than we saw in the thousands of years that came before the scientific revolution. So this is a huge turning point for humankind, this period, and we can really see some of the major events that occur during this period on our timeline of the scientific revolution. Now, the scientific revolution is going to begin when Copernicus publishes his theory, really challenging the previously established geocentric model. And notice that this is going to come after the period known as the Renaissance, as well as after the Reformation. And we're also going to see that the scientific revolution kind of happens concurrently with the period known as the Enlightenment. Thomas Hobbes is one of the early Enlightenment thinkers that's really kind of changing the way people look at government and politics and the way people interact with that institution. So the scientific revolution is part of a larger landscape of revolution in the way people think, the way people look at the world and their place in it. So now that we've had a chance to look more closely at the scientific revolution and some of the major events that occur during this period, let's take a moment to check in one last time with our lesson question.